All right, members. You're welcome to our YouTube channel once again. And this is Mr. Hyper. I'm going to take you through the reaction of benzene. And our lesson is organic chemistry. So I want us to look at reactions of benzene. So we are going to record a series of videos to show you the reaction of benzene or the reactions of benzene. So let's pay attention to this video and we learn our best. So we are looking at reactions of benzene. Right, basically, we are going to find that within benzene, it's the variability of the pi electrons in the ring that serves as the source of electrons. In other words, the pi electrons or the pi electron system serves as a nucleophilic reagent. And in these reactions, or in these reactions of benzene, we shall see electrophilic substitution, whereby in this, the electron deficient species, or what we call the electrophiles, substitute a hydrogen atom. We are going to see an electrophile substituting a hydrogen atom of the ring. And in this and other ring substitution reactions, we shall be forming an unstable intermediate in which the entering atom or group of atoms of the electrophile and the leaving group and the leaving hydrogen atom are both momentarily bonded to the ring, which will cause the disruption in the symmetry of the delocalized pi electron system. And at this stage, we shall be denoting that one with an incomplete circle inside the ring. And if the attacking species, is an electrophile, which is the most common, then the reaction intermediate will carry a positive charge, which is distributed over the bulk molecule. In other words, what I'm trying to say that if you have benzene ring, you need to take serious note and a keen interest when you're drawing this benzene ring. So when the benzene ring reacts with an electrophile or the electron deficient species, we shall realize that this electrophile will replace the hydrogen atom on the benzene. So we shall have with an E to denote an electrophile, then plus hydrogen ion. This hydrogen ion is as a result of the other hydrogen that was displaced. So basically, if one is outlining the mechanism here, I'm going to show you a simple mechanism that we outline. So when we are outlining a simple mechanism, simply here, we shall draw our benzene. And for simple terms, or for easy accountability, when you're doing this mechanism, then we call it accountability. Let's use the bonds, the benzene ring with a bond or with bonds. Then you bring your electrophile. Now, this bond supplies electrons. So it will give electrons to the electrophile. And what will happen is, we say that after it attacking the electrophile and the hydrogen are going to be momentarily bonded together. And at that instance, we can draw, we can illustrate the stage of the disruption of the pi system of the benzene ring. We can denote it using an incomplete circle, and then the hydrogen, right, and the electrophile will be bonded momentarily together. So by losing hydrogen, or by losing a proton, we are going to find that we shall form our benzene ring when we are having our electrophile attached. So this is how the mechanism will always be. Now, benzene undergoes electrophilic substitution reactions. When we say electrophilic substitution reactions, it means that an electrophile or an electron deficient species is displacing or is replacing hydrogen atom, all right? It is displacing the hydrogen atom, or it is substituting the hydrogen atom of the ring. That is what we call electrophilic substitution. Because in some of the questions, they can bring a question and they ask you to describe the meaning of some reactions or what is meant by some reactions. And then they say electrophilic substitution. And to get many marks, even though they have not told you, provided you see marks beyond 1, simply know that they want you to give an example, you outline the mechanism and the like. So now, benzene undergoes electrophilic substitution reactions. Benzene undergoes electrophilic substitution reactions, and these include nitration. These include nitration, these include sulfonation, these include halogenation, these include alkylation. These reactions include acylation. And maybe if there is others, we shall be seeing, but basically these are the reactions that we shall be interested in. So in this video, I'm going to talk about nitration and sulfonation. Then in another video, I will talk about halogenation, alkylation, and acylation, so that all the reactions of benzene which are common, we deal with them in this series of videos. Now, we are going to look at one by one. We are going to look at one by one, and then we see the logics behind this. We're going to look at the logics behind the reactions of benzene. So we are going to begin with the nitration of benzene, and we see what logic is behind nitration of benzene and how can we carry out the mechanism. All right, so we are going to begin with nitration of benzene. Nitration of benzene. Now, when we say nitration of benzene, here, this is the type of electrophilic substitution reaction whereby if we say nitration, it means that we are involving a nitro group. We are involving a nitro group. So here we find a nitro group, and that nitro group I'm talking about is NO2. So the nitro group in form of a nitronium ion. So we shall consider it is a nitro group that is taking part in the reaction, but we consider it in form of a nitronium ion. Okay, so the nitro group in form of a nitronium ion will be the one that will be replacing the hydrogen atom of the benzene ring. All right, and we are going to find that this nitronium ion, this one we've called it nitronium ion. Now, this nitronium ion, as you're seeing it, it is obtained or is formed by the reaction between concentrated sulfuric acid and concentrated nitric acid. So as you carry out this reaction or as you practice this reaction, simply know that the nitro group which is expected to attack or to replace the hydrogen atom in the benzene ring is used as a nitronium ion. But where do we get nitronium ion? Nitronium ion is obtained from the reaction between concentrated sulfuric acid and concentrated nitric acid. And therefore, the equation for the reaction, is benzene ring, all right? We add concentrated nitric acid, then also we shall add concentrated sulfuric acid. By warming, we shall get our compound referred to as nitrobenzene. So we shall have our nitrobenzene and water. So now this is what we are calling nitrobenzene, because sometimes they can say complete the equation and write the name of the product formed. So this is our nitrobenzene. So when we are outlining the mechanism, all right, before I go that further, I need you to know that when benzene is mixed with concentrated nitric acid and sulfuric acid, the mixture can be warmed or refluxed, all right? Can be warmed or refluxed, maybe in a water bath at 60 degrees Celsius. So let's consider temperature 60 degrees Celsius. We shall automatically form our nitrobenzene. Now, one may ask themselves, but what will be the importance of sulfuric acid? In this reaction, sulfuric acid is going to serve two purposes. Number one, sulfuric acid does the first function of protonating. It protonates nitric acid. That is first reaction. It protonates nitric acid. Reaction number two, or the function number two, after protonating the nitric acid, it dehydrates that protonated nitric acid to release a nitronium ion that attacks the benzene ring. So another role it plays is to dehydrate the protonated nitric acid to release nitronium ion. And this nitronium ion is the one that is going to attack the benzene ring. So the nitronium ion to be released is NO2 plus. So let's see these reactions in form of a mechanism. So our mechanism that we shall outline here is simple. We have said that sulfuric acid first protonates the nitric acid, all right? So the first thing it will do, we have our nitric acid. Because I'm interested in NO2, allow me write my acid, my nitric acid as NO2, then HO is the same as nitric acid. Because I'm interested in this NO2, so I'm just splitting it this way so that it is easy for me. Now, plus concentrated sulfuric acid. Sulfuric acid is there to protonate. Protonation, it is adding a proton. So here we shall have H2O, because by adding a proton, it means that now we are forming H2O plus, H2O plus, all right? Then NO2, then plus, remember one hydrogen has been used to protonate, so we have now hydrogen sulfate ion. So we shall have the hydrogen sulfate ion. Now, what happens is that it will also play another role of dehydrating the protonated nitric acid. The protonated nitric acid is this. So sulfuric acid will come again to dehydrate or to remove the water to dehydrate, is to remove the element of water. So what it will do, we shall have our protonated acid, protonated nitric acid. We shall add sulfuric acid again. And what will happen is that the sulfuric acid is going to dehydrate. And by dehydrating is by removing water. So what will happen? We shall form our nitronium ion, right, plus we shall form a nitronium ion plus H3O plus the hydrogen sulfate ion. So when you look at this equation, for us, we're interested in this, so one can take this because we've gotten our electrophile. Now, another person now can decide to write the overall equation. The overall equation that initiates the reaction. So whereby protonation and dehydration are all going to be considered in one. So one can write it as nitric acid. We have a nitric acid plus now 2 molecules of concentrated sulfuric acid. Why 2 molecules? Because 1 molecule is going to be used in protonation and another molecule is going to be used in the dehydration of the protonated nitric acid. So we shall consider 2 molecules of concentrated sulfuric acid. In other words, even one can look at how it has been evolved twice. So in this particular case, we are going to form a nitronium ion, NO2 plus, then plus H3O plus, then plus 2 hydrogen sulfate ions, plus 2 hydrogen sulfate ions. Now, our main point of interest is this electrophile. An electrophile is that substituent that is deficient in electrons, or the electron deficient species. So now, these species are the ones, or is the one that is going to attack, or is going to be used, all right, to attack the benzene ring. So, ladies and gentlemen, since I've gotten the attacking reagent or the attacking substituent, now allow me to take you to another page and complete my reaction. So what will take place is, we shall have our benzene ring. All right. So I'm going to bring my nitronium ion, which is my electrophile. So now the common mistake students do is bringing the arrow from nitrogen to the ring. No, this is electron rich. It is going to electron deficient species. So now this one is going to give you, we said that when the electrophile attacks the ring becomes unstable. The pi system is destroyed because already electrons have been given out. So now, but we said that at that particular case, you bring hydrogen and you bond it momentarily with the electrophile or the electrophilic substituent. So NO2. Now, what happens here is that after forming this, now you have got the hydrogen sulfate. So it is at this stage that the hydrogen sulfate ions will come. The hydrogen sulfate ions are going to come, and this hydrogen sulfate will pick the hydrogen, meaning at the end we shall form sulfuric acid. It will pick the hydrogen. The hydrogen has been picked. This is the arrow going to hydrogen, and as the hydrogen is picked, this bond will stabilize the ring again. So this one will lead to the formation of a nitro we form our nitrobenzene, and sulfuric acid. So this one will come and form sulfuric acid. Why are we forming sulfuric acid? It is simply because the hydrogen sulfate ions picked the hydrogen to form this proton, became part of this, and therefore you are forming a sulfuric acid. So the thing is very simple. It's a matter of knowing what role does concentrated sulfuric acid play, and after it playing that role, what follows? We say that concentrated sulfuric acid protonates nitric acid. So we form protonated nitric acid, which on further treatment with concentrated sulfuric acid will be dehydrated, thus releasing nitronium ion and hydroxonium ion. But nitronium ion is our attacking species, or is our attacking reagent, being an electrophile, right, is the one that will substitute the hydrogen. Then the mechanism is as simple as this. The electron-rich species will go to the electrophile and hydrogen will be momentarily bonded together as the pi system of the ring is destroyed. Then the hydrogen sulfate will come, making will come in, causing the stability again of the ring with the releasing of a proton, which proton forms sulfuric acid with the hydrogen sulfate. Ions as simple as that. Now, this reaction can take us, though we didn't intend to go there, but this reaction, after forming the nitrobenzene, this nitrobenzene can be used to do other things. For example, nitrobenzene can be used in preparation of phenylamine, or what we call the amino benzene. So one can get aminobenzene after getting nitrobenzene, right? And that nitrobenzene, rather the aminobenzene that we obtain, is normally used in manufacture of dyes and other colored reagents or substances, but basically dyes. So how do we use this before we go to sulfonation reaction? How do we use this one to get aminobenzene? It is a matter of treating. However, it is not part of our mechanism, but we are saying that this nitrobenzene, let me note it for you and say that nitrobenzene is used in preparation. We can use it in the preparation of aminobenzene, a very common reaction. Aminobenzene, it is one word, aminobenzene, which is used in the manufacture of dyes. And how does that one happen? If you have nitrobenzene, all right, this nitrobenzene, now even if you draw the ring, it is okay. If you have nitrobenzene, we treat it with the following reagents to get aminobenzene. Our purpose is to get amino. Our purpose is to get aminobenzene. Here we have NH2. So to get aminobenzene, we have to treat nitrobenzene with the following reagents. Number one, we treat it with tin and concentrated hydrochloric acid. Here we do some heating. And then reagent number two, we treat it with the concentrated sodium hydroxide. So these conditions lead you to produce aminobenzene, which aminobenzene can be converted into very many other things, including the diazonium salts and very many others, as we shall be seeing maybe when we get to amines. But for this purpose, I wanted to show you where the product is applied, because it is not that it has not gotten any purpose. It is used, or it is applied in the manufacture of aminobenzene, which aminobenzene can be used in the manufacture of diazonium salts, which diazonium salts can be used in manufacture of dyes and azo dyes and very many other things. So that was the first reaction of benzene. The second reaction we are going to discuss together is sulfonation. Let's look at sulfonation of benzene as our part B reaction. Sulfonation of benzene. When we say sulfonation, it means that we are adding benzene sulfonic acid group. Actually, we are adding the sulfonic acid group, sorry. We are adding the sulfonic acid group into the benzene, meaning that still, remember, we are still looking at electrophilic substitution reaction. So an electrophile will be the sulfonic acid group replacing hydrogen. So we shall form benzene sulfonic acid. So when we say sulfonation of benzene, here we shall have the hydrogen atom. Let me notify and say that the hydrogen atom, all right, of the benzene ring is replaced by, all right, by the sulfonic acid group, by the sulfonic, it is replaced by the sulfonic acid group, and that sulfonic acid group is SO3H. That is the sulfonic group. And this sulfonic group, the sulfonic acid group, is obtained from, where do we obtain this? We obtain it from fuming sulfuric acid, right? It's obtained from fuming sulfuric acid. So, and what special thing is in that fuming sulfuric acid? It's obtained from fuming sulfuric acid, all right? Containing, that fuming sulfuric acid contains excess sulfur trioxide. As simple as this. So in other words, excess sulfur trioxide, we are just going to derive sulfur trioxide in our thing, and we see how the reaction takes place. Alternatively, one can use ordinary concentrated sulfuric acid, but the mixture will be required to be refluxed, maybe for some several hours. So one can write the equation as, benzene ring. All right, we have a benzene ring, and this benzene ring is reactive with sulfuric acid, but this sulfuric acid should be fuming. So you're going to form your benzene sulfonic acid. And water. Alternatively, one can have the benzene ring reacting with concentrated, that is at ordinary conditions. So with the concentrated sulfuric acid, and here you are going to reflux. So this one will require refluxing for some hours, and still this one will form for you, or will produce for you, the benzene sulfonic acid. You have to take a note in drawing the structure of benzene, then plus your water. Let's see how best we can outline the mechanism of this. How best we can outline the mechanism of this. Now, the mechanism will all begin with the excess sulfuric acid. We begin with excess sulfuric acid ionizing, what is reacting to form sulfur trioxide, because this is what we are interested in, and we shall form sulfur trioxide and hydroxonium ions, and then hydrogen sulfate ions. But our main interest is this, the sulfur trioxide. So what happens? What happens is that you have your benzene ring. All right, we shall have our benzene ring. Then we bring our sulfur trioxide. All right, we shall have our sulfur trioxide. So as we have seen, this, the pi system is rich in electrons. So is electron deficient, so it will be attacked, and this bond will get off. And as that one happens, you're going to form the unstable compound, because by losing an electron, or by losing electrons, or by giving away electrons, the pi system of the benzene ring is already destroyed. So what will happen? Is that you're going to have the unstable pi system, and we say that that one, we draw it with an incomplete circle, and then this hydrogen, at every corner of a benzene ring, there is a carbon and hydrogen. So here we shall have a hydrogen, which would be momentarily bonded to the sulfur trioxide. All right. So we have this. After removing a bond, after gaining electrons, it's going to become negatively charged. So that's why our oxygen is negatively charged. So now what happens is that this minus will pick the hydrogen, as this bond of hydrogen stabilizes the ring. And this one will automatically lead you to form benzene sulfonic acid with a lot of ease. So we shall form benzene sulfonic acid. As simple as this. This is a very common and crucial questions, but it is easy. Just need to know that hydrogen atom of the benzene ring in this reaction is replaced by the sulfonic acid group, which is the minus SO3H, and that one is obtained from fuming sulfuric acid, which contains excess sulfur trioxide. So when you're having your benzene ring plus the sulfuric acid, to get this, the mechanism is all about first having the sulfur trioxide, which is obtained from excess sulfuric acid, or the sulfuric acid molecules are going to give you the sulfur trioxide, and this sulfur trioxide is the one that we are using as our electrophile. So we shall have our sulfur trioxide being considered as our electrophile. Don't forget the definition: electrophile, the electron deficient species. All right, so the pi system of the benzene is rich in electrons, so they will attack the electrophile, and that electrophile at the end of it all will end up forming. Don't forget that this step, at this very stage of forming an intermediate, the hydrogen and the electrophile are momentarily bonded together. So it is what you do here that will cause the product appear like this. So we have said that here the oxygen picks the hydrogen so that it is part of the product, and that's why we are having benzene sulfonic acid. As we saw for nitration, we said that nitration reaction can be applied in the manufacture of aminobenzene. However, sulfonation reaction can also be applied somewhere else, whereby this product you've gotten here can be used to do any other thing. So maybe, let me also include it, though it wasn't too much necessary, but we need to know it. We need to know that this benzene sulfonic acid we formed can be used to prepare hydroxybenzene, or what we call a phenol. And that phenol can be used in manufacture of nylon, bakelite, nylon and plastics, and many other things. So let's see how we can use this benzene sulfonic acid to obtain phenol in simple terms. because it is not too hectic, we can go with it from here. So we need to know that benzene, sulfonic acid, is basically used to prepare hydroxybenzene, commonly known as phenol, which is used in the manufacture of nylon, plastics, and others. So let's see, how do we convert benzene sulfonic acid to hydroxybenzene? So we are going to have our benzene sulfonic acid. So what you do, you add aqueous sodium hydroxide. So by adding aqueous sodium hydroxide, we're going to form a salt of benzene sulfonic acid. So after forming this, of course, plus water, that salt we formed is fused with the solid sodium hydroxide. So we are going to fuse that salt formed with the solid sodium hydroxide. So we shall have sodium hydroxide solidly and then fuse, leading to the formation of so here we form sodium phenoxide. We form sodium phenoxide, of course, and some sodium sulfite, then and some water. Then by carrying out acid hydrolysis, we shall hydrolyze the sodium phenoxide So we shall carry out acid hydrolysis, whereby we shall use dilute hydrochloric acid, and this one will give you your phenol, which phenol can be applied in very many other things. So we shall form phenol and sodium chloride, whereby this H will appear here and the sodium will combine with the chloride to form sodium chloride. So as simple as this, benzene sulfonic acid, you can use it in obtaining phenol, meaning that by the time we reach phenols in our discussions, you should be at least be able to retrieve and remember how we obtained phenol using benzene sulfonic acid. There can be synthesis. Let me give you an activity here. Obtain or synthesize phenol from benzene. Call this one part 1. Then 2, obtain phenylamine from benzene. So this is as easy as you can imagine, because if I need phenol from benzene, it means that you will first get benzene, you add sulfuric acid, which is fuming, you form benzene sulfonic acid. from benzene sulfonic acid, you continue like this. You add up your sodium hydroxide, you form a salt of benzene sulfonic acid. Then that salt, you fuse it with sodium hydroxide. You form, with solid sodium hydroxide, you form sodium phenoxide. Then the phenoxide is hydrolyzed using a dilute acid, which gives you phenol direct. So in our next video, I'm going to be talking about halogenation, alkylation, and acylation. So stay tuned, members, and I request that you subscribe, you like our channel, you subscribe to it, you share, and every other thing you comment. We shall be very grateful. See you in our next video. Thank you for listening.